solving exponential equations, there are several different forms that exponential equations may take on. The first type, we notice that we have like bases, so 2 is the same base, and then they're both raised to an exponent. So it should make sense that when you look at 2 to an exponent equals 2 to an exponent, the exponents must be the same. So just using numbers, 2 to the 6th would have to equal 2 to the 6th. 2 to the 9th would have to equal 2 to the 9th. So as long as the bases are the same, the exponents must also be equal. So all we do here, as long as we have the same base, you set the exponents equal to each other. So if you set the exponents equal to each other and solve, I'll show you the answer so you can pause the video. In part A, notice that we get x equals 3, and you should always substitute your answer back in to make sure that it does work. So 3 plus 5 is 8, and then 3 times 3 minus 1 is 9 minus 1, which is also 8. So it is true that 2 to the 8th equals 2 to the 8th. Part B is similar idea. You get x equals 1, and you get e to the 5th equals e to the 5th. And then in part C, this one's a little more complicated. We have a quadratic in the left-hand exponent. So you set the exponents equal to each other and solve. That one solves by factoring, and you get x equals 6 and x equals -1. And just remember to substitute them both in to make sure they work. And in this case, they do. I'm not going to go over that, but you can check it. The next type is solving exponential equations by inspection. So what that means is, if we have 2 to the x equals 16, you want to think about how many times do you multiply 2 by itself to get 16. Well, we know if we multiply 2 by itself 4 times, you end up with 16. So that's just x equals 4. So that's a pretty straightforward, easy one. So try the next two. And again, pause the video if you need, and I'll show you the answers. And we know that 3 to the 0 is 1, and 4 to the 2nd, or 4 squared, is 16. So by inspection is always an easy way to solve if you can. Now, unfortunately, many of them you won't be able to solve that way. But you should always kind of do a mental check. So when we get to number 12, you might think, well, the next logical type of question is, what if we can't solve by inspection? We can't just plug a number in and see if it works. So if we have 2 to the x equals 20, so looking at that equation, we know that 2 to the 4th is 16, and 2 to the 5th is 32. So we know that our solution for x should be somewhere between 4 and 5. So right now, we're going to solve graphically. So the way we're going to do that is we're going to go to our calculator. We'll put y1 equals the left-hand side of the equation, 2 to the x, and y2 equals 20. Now we have to make sure that our window is going to fit that value in, or all those values. So the y maximum, we have to fit 20 in there, so I'm going to put 30 just so it, oops. So the 30 will allow it to show up. So now if I press graph, here comes y equals 2 to the x, and then 30 will be a horizontal line. So I just want to find where they intersect. So second trace, that'll be calculate option 5 is the intersection. So first curve, enter, second curve, press enter, and then guess, just press enter again, and we get 4.32. So the first one is x equals 4.32. Now, as far as showing your work and something that I want to see work for, just show a sketch of the graph. And then in this case, our solution is x equals 4.32. Okay, the next couple, there's a little more going on than just 2 to the x equals a number. So there's two different ways you can do this. One way is you can isolate the exponent term. So we can add 6 to both sides in part B, and then do 2 to the x equals 36, and then solve the same way we did in part A. Or you can always say the left-hand side of the equation is y1 and the right-hand side is y2. That's up to you, whichever way is more comfortable. A lot of people will tell you to isolate the exponential term because then you have them all the same form first. So if you add 6 to each side, you're going to have 2 to the x, which we know what that looks like, and then equals 36, just a horizontal line of 36. So I showed it by just keeping it left-hand side. Okay, so that's what your graph looks like. If you added 6 first, you would just have the exponential shifted up 6. So it'd be a curve right here, and then 36 would be a little bit higher. But they would intersect at the same x value of about 5.17. Okay, and then the last one, you can divide by 4 first if you want. What you can't do is you can't say 4 times 2.5. A lot of students make that mistake over and over again. But it's with an exponential, remember order of operations, you have to apply the exponent first. And we can't just raise 2.5 to the x if we don't know what x is. X is your variable. So you can divide by 4 first to get 15 on the right side, or if you leave it like this, and then put y2 equals 60, and you get 2.96 for that answer. So that's solving graphically and rounding to the nearest hundredth.